Okay, yeah, just before we kick off the event, I'll go through some housekeeping and then we'll go straight into it. It's going to be another exciting event. Here, basically a quick itinerary for tonight. We have got Julien from Argent X, who's going to go through kind of StarkNet wallets for us. Then we have a bit of a Q&A with him. And then we're going to go into a bit of Cairo with Henry, which is going to be fabulous. And then just first off, hello to Julien, hello to Henry. Welcome to another event. Thank you so much for being here. We appreciate you here. And last night was so awesome. So yeah, we're looking forward to tonight. I find it really engaging as well, which is awesome. So today we got Vanessa. She's going to be on links. Just a quick heads up on why we actually do the links in the chat. Just because Zoom doesn't actually save any chat history. So when we post the recordings on YouTube, you can't see any links there. So that's why we post them. So if you do want to kind of keep anything open, just open it and then you can revise it later. Basically just a quick catch up. Please join the Discord if you haven't joined the Discord yet. That's kind of where all the communication happens. Anything on Twitter, please just tweet, tag us, tag StarkNet, tag Argent X. You'll hopefully get some retweets. And if you haven't booked a one-on-one call yet, please book a one-on-one call with me. I'd love to chat to you, love to know what you're building, what your idea is. And the YouTube is posted on the Discord, as you saw this morning. So if you have an opportunity, you can rewatch it. And the last thing is that engagement was unreal last night. It made Henry's life so much easier. You asked him such good questions. He really appreciated it. So please have the same sort of engagement tonight. We really love an engaging crowd and audience. So over to Julien from Argent X.
Fantastic. So my name is Julien. I'm one of the 3 co-founders at Argent. But today I won't talk much about Argent, but I will focus on StarkNet and specifically on accounts and wallets on StarkNet. So what I will go through, I will first discuss Ethereum accounts, because I think as a Dapp developer, if you want to understand StarkNet accounts, it's good to understand Ethereum accounts and see the differences between the two. So going from Ethereum accounts, we'll see some of the limitation of the existing model, and that will lead us to account abstraction, which is the model that StarkNet is implementing. And I will conclude the account abstraction section with basically what it means for you as Dapp developers. So trying to be as concrete as possible to make sure you leave this talk with a few bullet points that you can remember, that you can take with you when you start building on StarkNet. Next, I will illustrate account abstraction with some use cases. And for that, I will use Argent X, but I will see some of the cool stuff that are now possible on StarkNet because of account abstraction. And finally, I will give you a few links on how to get started building on StarkNet with a wallet and with Argent X in particular. So for all of you that are very familiar with Ethereum, I apologize if this is common knowledge, but I do think it's always good to sometimes take a step back and highlight some of the key concepts that we tend to forget when we use a platform. And so that's why I want to focus on Ethereum accounts first. So as you all probably know, there's 2 types of accounts on Ethereum. You have externally owned accounts, abbreviated, or we call them EOA, and then you have contract accounts or smart contracts. And the state of Ethereum is just the state of all these accounts. And when we say that the state of Ethereum is growing, it's basically the state of all these individual externally owned accounts and contract accounts. As you all probably know, the state of Ethereum can only be updated by transactions. And what's interesting is that the state can only be updated with an external trigger, which means that every transaction must be initiated from an EOA. So when we talk about a transaction, we always have a from, a to, some value. The from is actually the address of an EOA. That means that on Ethereum, every time the state is transformed, is updated by transaction, this transaction must start its journey from an EOA. It can then ping smart contract and so on, but the entry point of the blockchain of every transaction is always an EOA, and that's why we call them externally owned accounts. As you all probably know as well, an EOA has basically 3 key properties. It has an address for identification, it has a nonce to make sure that transactions are unique, and it has a balance in Ether, basically to pay fees. This EOA is owned by something external to the blockchain, typically a user, and this connection is done through a pair of cryptographic keys or a cryptographic signer. And how is the link between this cryptographic object and the account made? It's because the address of an account is actually derived from the public key of a key pair, and only the private key can sign transactions that are initiated from the account. So every time there's a transaction on the blockchain, it must start from an EOA, and actually, so from an account, and that transaction must be signed by the private key corresponding to that account. Okay, this time, don't worry about this slide. I will go quickly through it. But again, I think these are some interesting concepts that will lead us to account abstraction next. So again, a cryptographic signer is a pair of public and private key. You can derive the public key from the private key, but you cannot do the reverse. So if I give you my public key, you have no way to know what's my private key. And with this private key, you can generate signatures on digital message, such that basically, if I give you a signature, you know that only the private key could have signed that message. And anybody with the public key can verify that signature. And actually, these key concepts are underlying how Ethereum works. So on Ethereum, these signers, they are not used arbitrary. They are used in a signature scheme called ECDSA. And ECDSA is implemented on a very specific elliptic curve called SECP256K1. All this crypto jargon is not that important, but what's interesting is that these things are very specific. So on Ethereum, you use ECDSA and you use that specific elliptic curve. So just bringing these few introduction slides together and highlighting the key concept, we see that on Ethereum, we typically have a signer, so a pair of private and public key, and that signer is associated to an account which has an address derived from the public key, some state, and then some hard-coded logic in the EVM to validate and execute transaction. But actually highlighting these two concepts, we see something very important about Ethereum is that on Ethereum, these two concepts, they are basically merged. They are basically the same thing. Typically, if you have the signer, you automatically have an account because you have a private key and you can derive the address from the public key. So having the signer means that you have the account. And as a Dapp developer, we tend to think that they are exactly the same thing. And actually they are not, and that leads to some of the limitations of Ethereum, because the account is the object that holds your funds, holds your token, while the signer should be just an object that's authorized to spend these tokens, to make transactions, but they should not be the same thing. So that's the first thing that I wanted to highlight about Ethereum account, is that on Ethereum, these two concepts, they are typically merged. So they are basically two sides of the same thing. You have the key, you automatically have the account, and if you control the account, that means that you have the keys. Okay, so on Ethereum, the signer is the account, and again, that was done for some good reason. One, it's easy to understand. If you have a private key, if you have a cryptographic signer, you have an account, that's more or less easy to understand. And it's also very permissionless, that meaning that anyone can generate a private key locally, and you automatically have an account on the blockchain. You automatically have an identity. So that's quite powerful. But of course, there's a drawback to that approach. And the main one is because the signer is the account. If you lose the signer, but then you've lost the account. If your signer, so your private key is compromised, that means your account is compromised. And we've all heard about hundreds of stories of people having their private key lost or stolen and basically losing all their funds. So this basically highlight also that on Ethereum everything is fixed. It's kind of a one-size-fits-all. It was done for good reason. When Vitalik and the early developers started building Ethereum, that was the simplest way to get started. And all these people, they were computer scientists or hackers or PhDs. They knew what a cryptographic signer is. They know what a private key is, and so they could manage these objects. But of course, the problem is because this logic is hard-coded and there's only one logic, the question is, will it work for mainstream adoption? And I think we can all agree that this will probably not scale to mainstream adoption. asking your mother or your brother or your uncle to manage a cryptographic key is something that's complicated. So the question is, can we do better? And the answer is yes, we can do better. Actually, Vitalik himself has been trying to push for account abstraction on Ethereum almost since day one, because he recognizes the limitation of the existing model. And that's what's very exciting about layer twos like StarkNet. It's because in a sense they are a blank page. They can take all the best from the designs of Ethereum, but they can improve on the little topics that should have been done better on Ethereum. And one of these topics is account abstraction. So what is account abstraction? Well, I tried to illustrate on the previous slides that on Ethereum, the concept of the account and the signer are tightly coupled. Basically, the idea of account abstraction is to decouple the relation between the account and the signer, really making the account the object on the blockchain that holds your fund, and a signer just being some cryptographic material that can be used to spend those tokens. But what's interesting is that the account can define its own logic. It's not something that's hard-coded in the EVM. It's something that can be programmed in the account, because with account abstraction, the account is a smart contract. And so, of course, that becomes interesting, because you can imagine an account which uses a different signature schemes than ECDSA, or that uses a different elliptic curve. Or you can imagine an account that's actually natively a multisig, where there's multiple signers that needs to authorize transaction. Or you can have an account where the signer can change over time or can be replaced. So suddenly putting that freedom and that liberty at the account contract opens us a lot of interesting use cases that haven't been explored on Ethereum. And so on StarkNet, because the account is a contract, of course, it cannot be an arbitrary contract. It needs to be a contract that complies to a very specific interface. And this interface is the following. I don't know, I guess most of you are not yet familiar with Cairo. The language is not that important, but there's on that interface, there's actually a few methods that highlight really what an account is on StarkNet. So the first one that I want to highlight is this one. It's called isValidSignature. Why do we need that? Well, typically on Ethereum, when you build a Dapp, for example, and you want a user to prove that he owns a specific account, you will ask that user to sign some random message, and then you will verify the signatures locally, and you will recover the public key. And because the public key is linked to the account, you know that actually this signature was generated from that account. But of course, on StarkNet, because the account is now a smart contract and there's a decoupling between the account and the signer, you cannot verify locally a signature. Only the account himself can tell you if a signature is valid. So that means that as a Dapp developer, if you ask the user to sign some random message, you obtain a signature that was signed with the signer. The only way to make sure that this is a valid signature from an account is actually to ping the account on chain and say, hey, can you verify that signature? Is that signature legit for yourself? So that's the first method, isValidSignature, very important. The other two methods, it's a bit more low level from your point of view, but they are execute and validate. Basically, these two methods needs to be there for the virtual machine or the Cairo OS, in the case of StarkNet, to make sure that the contract, the entry point of a transaction is indeed an account, and to actually validate that the transaction is correct and that it will pay fees to the miner, and then to execute the transaction. So these two methods are less important for you as a Dapp developer, but they're still part of the account interface. And so today on StarkNet, there's two implementation of this e-account interface. That means there's two flavors of a potential account on StarkNet. One was designed by OpenZeppelin, and that's basically a NeoA-like implementation of an account on StarkNet. So it's an account that has one signer signing on a specific curve, and that can execute transaction. A second implementation is the one that we've developed at Argent, and I will come back to that later, because it illustrates or highlights some of the possibilities of account abstraction, and we've made an account with a few interesting properties. Oh yeah, one last thing that I did not mention is that if you're looking at that interface, you see that the parameters of the execute is actually an array of call. That means that on StarkNet, we will have natively multi-calls. And again, I think that's something to cheer and to be excited as a Dapp developer. For those who don't know, the idea of a multi-call is that instead of executing in your transaction just one operation, say calling one smart contract that will then carry on and do something on the blockchain, you can actually, in one atomic transaction, execute a sequence of operation. And a typical example is to do an approve and call. As you all know, when you build a Dapp and your Dapp needs to consume some tokens, the user has to make two transactions, one to approve a certain ERC20 and a second transaction to call a contract that will consume this token. With multi-call, you can do that in one atomic transaction. So that means from the user, it's just one click and automatically the account will execute the sequence of operation on the blockchain. For those who are still following, and I hope the majority of you still are, what does all this mean for you as a Dapp developer? Well, there's really just 5 things that you need to remember when you start building on StarkNet. And they're actually the 5 key differences between StarkNet accounts and Ethereum accounts. The first one is that the account is a smart contract. And of course, as a Dapp developer, that's very important because a smart contract needs to be deployed, for example. So when you build a wallet, your wallet needs to deploy a smart contract that will act as an account. So that's something that you may need to consider when you're building the flows of your Dapp. The second thing is that the address of the account is no longer derived from the signer, is no longer the hash of some public key. Because the account is a smart contract, its address will be derived by the mechanism of computing smart contract addresses on StarkNet. So that will take into account the bytecode, the input parameters, some salt, and so on. So again, whatever cryptographic material the user may have to sign transaction, this will not be sufficient to derive the address of the account. The third point is, as I illustrated before, because the account can choose it and have its own logic to validate transaction, and you can have, for example, a multi-sig, that means that when you have a signature for a transaction, it can actually be multiple signatures because maybe it's a multi-sig with multiple signer. So again, when you build your Dapp, you write your smart contracts or you write the front end of your Dapp, you need to remember that when you have a signature, it can actually be an array of signatures because there's multiple signers that needs to authorize a transaction from a given account. The fourth point is related to this valid signature, is the fact that if you need to validate a signature on an off-chain message, you cannot do that locally. You need to call the account and ask the account, is this signature valid? And only the account can tell you if a given signature is valid. So for those of you who are used to use EC recover on Ethereum, this will no longer work on StarkNet. Instead of using EC recover, you will need to call the account and say, is valid signature, and provide the same parameters, the message and the signature, and the account will tell you, yes, this is a valid signature, or no, this is not a valid signature. And finally, as I mentioned, you also have multi-calls. So these 5 points is really all you need to remember about this talk. You can forget everything that I've said before. You can ignore everything that I will say after that. If you remember these 5 key points, you're good to go and you understand accounts on StarkNet. Okay, now I'll try to be a bit more concrete and illustrate what account abstraction means. So what kind of account you can build on StarkNet. And I will illustrate that with Argent X because it's the only wallet today on StarkNet. It also happens that's the only wallet I'm working on, but it's truly the only wallet on StarkNet today. So I think it's the best starting point to get you up to speed. So what is Argent X? For those of you who don't know, Argent X is the first wallet on StarkNet. It comes as a Chrome extension. You can have multiple accounts. It runs on all the StarkNet networks. You can send and receive tokens, and you can interact with dApps. So basically, you can think of Argent X as the equivalent of MetaMask, except that it's not MetaMask, it's Argent X, and it runs on StarkNet. Okay, so how does Argent X work? Or how does any wallet works on StarkNet? Now that you know that on StarkNet an account is a smart contract, actually Argent X is just more than a UI managing a private key. It's actually a UI, a signer, so a private key, and an account contract that is deployed on chain. So on Argent X, every time you create a new account, actually Argent X, the extension, will deploy an account contract for you on the blockchain. And so how does that connect to a Dapp? Well, that's the flow that you are certainly familiar with. It's the same as on Ethereum with, say, MetaMask, for example. If you click to, the user clicks on a button on your Dapp, that will ping Argent X. Argent X will ask the user to authorize the transaction. If yes, it will use the key, the signer, to sign the transaction. It will send that to the account contract that will then execute the transaction on the blockchain and call, say, your Dapp contract. Because you are developers, you probably want to know a bit more. Well, typically on Ethereum, if you develop a front end, you use web3.js or ethers.js. On StarkNet, it's exactly the same. You will use StarkNet.js, so a JavaScript library to interact with StarkNet. And actually, what Argent X does is that it will inject a signer into your StarkNet object, so that it will be completely transparent to you. So as a Dapp developer, the only thing you need to do is program against this StarkNet object and say, call the blockchain, send transaction, and so on. And then Argent X will automatically pop up and do the required operations. Okay, now that we know what an account is, hopefully, we also know what a wallet looks like with the example of Argent X. Let's see some example of some of the use cases that we can do with account abstraction and that are really unique to StarkNet and account abstraction. These kind of use cases, we've built them on Ethereum with Argent, the mobile application, but it was really, really complicated, and there's a lot of added complexities because I would say smart accounts were not first-class citizens. On StarkNet, because of account abstraction, we can really put that logic at the entry point, the user account. So a first example that I think is quite interesting is the idea of fraud monitoring. Because your account can be programmed the way we like, in Argent, actually, the underlying accounts, every time you use Argent X, is an account that has a signer, but it also has the possibility to have a second key that we call a guardian. And if this key is present, every transaction needs to be signed by the two keys. So if there's only one key, then everything can happen with the signer. But now if you decide to add that second key, every transaction needs to be executed with the signature of both keys. Now let's imagine that this guardian key, this second key, is controlled by a service. Let's call it a fraud monitoring service. Why is that interesting? Because every time the user will try to make an operation on a Dapp to do something, Argent X will send that information to the fraud monitoring service and say, hey, is this transaction secure? If yes, send me back your signature. So if the Dapp seems to be legit, the fraud monitoring service can inspect the call that is requested to be made, can use whatever logic, it can use a whitelist of Dapp that it trusts. I mean, it doesn't really matter. But the fraud monitoring service can conclude, yes, this is a legit transaction. It's safe for the user. Here is my signature. Then Argent X will use its own signer key to co-sign, send the two signatures to the account, and the transaction is executed. Now let's imagine that the Dapp is evil. It pretends to do something nice on the blockchain, but instead it will call some evil method on some smart contract. Argent X will do the same. We'll take this call that the Dapp wants you to sign. We'll send that to the fraud monitoring service. Say, hey, is this secure? If yes, send me your signature. The fraud monitoring service will inspect the call data, inspect the contract, and say, no, this is not a secure transaction. You're calling an evil contract, and it will refuse to sign the transaction. Or maybe it will just warn you and say, this is a sensitive or dangerous transaction. If you want to proceed, prove me that you are you, and maybe use a second factor, email, phone, or whatever. So that's this fraud monitoring ID is actually quite powerful. We all know that on Ethereum, a big problem is to actually connect to hacky website that will try to phish your private key or try to make you sign an unauthorized or dangerous transaction. Well, because we have account abstraction and we can have these two keys, and one of these keys can be controlled by a fraud monitoring service, suddenly the user can actually navigate the blockchain in security, because there's a service that will tell him, this is safe or this is not safe. And it's still 100% non-custodial, because if you want to dig into the detail, the signer can remove the guardian at any point. So now suddenly, thanks to account abstraction, we can have at the entry point of accounts, we can have, say, so that's really an amazing improvement in terms of user experience. Let's have a look at a second use case that's called recovery, or some people call it social recovery. That's actually something that we pioneer on L1, and again, that we are bringing to StarkNet, but this time really in the logic of the account. Again, the idea of social recovery, it's very similar to what I described before. You have two keys. You can give one key, say, to a service. There's many ways to implement social recovery. So here I'll just present a very simple and naive way, but hopefully you'll get the idea. So there's a service that holds this second key, this guardian key, and Argent X as the signer. Now, for whatever reason, maybe your computer is stolen, or your computer crashes, the key is lost. So your signer key is lost. In a typical scenario on Ethereum today, if you lose your private key, unless you have it backed up on a seed phrase, you've lost access to your account. Here, there's not even need to have a seed phrase. If you lose your private key, the signer, you can contact the recovery service, prove that you are you. This may be done through email, through phone, through a video call, through your passport. It doesn't matter. As soon as you've convinced the recovery service that you're indeed the legit owner of this account, the recovery service can sign a transaction that will replace the signer key, and you automatically get back access to your account. For security reasons, this is a process today on Argent X that takes 7 days. That means that you have time to cancel if for some reason the recovery service is not acting the way it should be, but it's still 100% non-custodial. And that means you can forget about seed phrases. Again, I think these kind of improvement to the user experience are the things that will actually bring the blockchain to a mainstream audience. Because now, thanks to account abstraction on StarkNet and social recovery, there's no need to back up a seed phrase or to know what a seed phrase is. Users can automatically create accounts on Argent X. They can connect that to a recovery service or give that second key to a friend. They can do what they want. And suddenly, they can be guaranteed to get back access to their account, even if they lose the signer private key. A third use case that I find quite interesting is the possibility to use the secure enclave. On Ethereum, as I mentioned before, there's only one signature scheme and one elliptic curve. But because you have account abstraction and you can program the logic, the validation logic that you want in your account, there's actually a very smart developer that created a library a couple of weeks ago on Cairo to enable to use an elliptic curve, which has been approved by the NIST. And it's actually the curve that resides in the secure enclave of your phone. So if you have a relatively modern iOS or Android phone, there's a small security component, physical component in your phone called the secure enclave that can actually manage keys, so generate keys and use these keys to sign transaction. And it uses that keys that is now implemented in Cairo. So what it means is that basically now every user with a smartphone has basically a hardware wallet in his pocket, because you can use your phone exactly as you would use a ledger or any hardware wallet. There's actually a physical component that can secure your keys. And you can imagine connecting that to your Argent X wallet, and suddenly all your transactions are approved with your phone, which act as a hardware wallet. So these three use cases, they're just there to illustrate the possibilities that you can do with account abstraction, but actually the possibilities are endless. And I think that's something that's very exciting for you, Dapp developers, as part of this hackathon, is to think what kind of new use cases you can imagine that will improve the user experience on StarkNet and really bring blockchain closer to mainstream adoption. Okay, now to kind of conclude my talk, if you want to be concrete or to get started, it's actually very easy. I mentioned that as a Dapp developer, you need to program your front end against StarkNet the StarkNet object or StarkNet.js. Actually, we've built a small NPM library, get StarkNet, that you can use in your Dapp. And by just saying that StarkNet, it's get StarkNet, it will basically check if Argent X is installed. If it's not installed, it will prompt the user to download it. And if it's installed, it will inject Argent X as the signer into your object. And that's it, you're good to go. So basically supporting Argent X is your Dapp is literally 3 lines of code. And now it's time for you to start building. So if you want to have a few links, you can download Argent X, you can check get StarkNet, you can contribute, you can ask me question on Discord, and hopefully after a few of these sessions, you'll be able to build amazing dApps on StarkNet.
Great stuff. Thank you, Julien. We really appreciate that. Just a quick heads up, if you got any questions that weren't answered, please just send them again in the chat and then Julien will answer them. Yeah, Julien, if you can just read the chat, all the questions will kind of come through there.
Yes. So in which order should I go? Is this recovery service a centralized system? So that's a very good question. So I illustrated that with a very simple example. What's interesting is that social recovery at the level of account is just a protocol. So you can give that extra key to whoever you want. You can actually have many of those keys. For example, on Ethereum with Argent, you can have an unlimited number of guardians, and these guardians need to act collectively. So it's really up to you. This recovery service can be a centralized service that you may trust, and as soon as you don't trust, you can remove and use a different one. So this service never has control of your funds. It can only act when you need to reprogram your account with a new key. But of course, you can give that to a friend. You can actually use a hardware wallet that you put in the bank that we use as your recovery service. So it's completely up to you. It's really, in a sense, it's a protocol. So you're free to do what you want. The idea is to have a smart contract as a wallet. Yes, exactly. I mean, for those who know Argent, that's what we've been building on Ethereum for the past 4 years. But again, maybe repeating myself, on Ethereum, smart contract wallet are a second-class citizen. The example of verifying signature of chain and EC recover, these kind of small details, we're actually breaking flows for smart contract wallet because that developer are used to EOA wallet, to having the concept of the signer and the account being merged. So we've tried to make it work, but we had to add a lot of complexity on top of that. Now on StarkNet, with account abstraction, smart contract wallet will really become, first-class citizen. They are the default entry point for all your transactions.
Actually, yeah, there were 2 questions I think are cool to answer. One is, can I use a ledger with Argent X to secure my private key? I think the broader question here that I think I'd be interested to have your opinion on is, we're very used to having to secure private keys when we have ledgers and things like that. And Argent X is not exactly like MetaMask. Like, you're right, your goal is not to secure a private key. It's different. Can you expand a bit on that?
Yes, definitely. So yeah, the focus of Argent X is first the account, the contract account that is deployed, and that contains this logic. And as I mentioned, this logic enables you to have a signer, but also to have a guardian. It's actually a third key that we call the guardian backup. So we have Argent X manages this account for you. And today we provide you a default way to manage the signer. But of course, the idea is to let users have different types of signer. So to be concrete, we are today working with Ledger to enable you to use Ledger as your signer for Argent X. So we already have a proof of concept, and we're working into a production solution that will let you sign transaction with your Ledger through Argent X. So when you create an account, we'll ask you, do you want a default signer or do you want to connect a Ledger? If you say Ledger, then automatically we will use the key that is secure by your Ledger. We are also discussing with Taurus. So maybe you will use Taurus to actually sign transaction. So yeah, Argent X will really be it's the UI, it's the entry point, it manages the account, it manages the connection to signers. But yes, you will have the possibility to use different types of signer on Argent X.
Super cool. And then somebody asked, can I access my private key in Argent X? I think when you install in Argent X, you download the backups. You can probably unencrypt it, but by default, the UX does not give you that opportunity, right? Nor
no. So that's a choice that we've made today. And is that no, you cannot export your private keys. Again, because there's a decoupling between the account and the signer in a sense is a disposable. So I don't think users should have access to these private keys or have the possibility to export these private keys. That we may change our mind in the future if a lot of users are asking for that. But today, the idea is that this private key is, with the default solution, is encrypted in this backup file. But no, you should not have access to it. What you can do if you want to control your private key is that you can actually reprogram your account using the default private key to reprogram your account and set up a new private key that you fully control. But we don't think that it's necessary to export it as is.
What's really cool with account abstractions and account smart contracts is that you can go wild with the logic you can imagine. Like, for example, you could have a wallet. I mean, I'm thinking out loud, okay? But you could have a wallet where you instead, for a signer, you could have a key or you could have a seed, right? And for each time you're signing, it could increment the index in the derivation path, and you would sign with a different private key every time you sign a transaction.
Yeah.
And it would that's super cool. And I like it because in the chat I see some people are actually like saying, oh wow, but this opens the door to this, to that. Arpal is asking, is it possible to add signer with conditions, like a signer with a spending limit, or a signer that can only sign ERC 721 type of transactions?
Yeah, so I mean, all these use cases, the answer is yes. For those who've been early users of Argent, you remember that we had daily limits. So even on L1 on Ethereum, we tried to implement that, again, with a lot of complexities. With gas, everything was expensive. But all this is easily doable with account abstraction. You can have signers that have spending limits. You can even imagine, as if you're building a game, for example, you can have an account where you can have ephemeral keys that will only last for a session. So when you're building your game, the user signs the first transaction to approve that game. Throughout the session, you will sign with this ephemeral key that maybe is valid for 5 or 10 minutes. And after that, the key is no longer authorized to spend tokens or do transactions. So the possibilities are really limitless. Yeah.
And it's also a really great avenue to facilitate onboarding new people, right? Because, I mean, so the question of fees on StarkNet right now is still up in the air. I mean, it's not yet implemented. It will be rolled out in the next few weeks. But fees are paid at the contract level. But there's nothing saying that a specific contract has to pay the fees. They have to be paid by someone. So you could have a service where basically you pay fees for your users. Say you want to onboard them very easily, you don't want them to pay their fees in ETH straight off the bat, or you want, maybe some user want to pay a fixed fee every month to be able to have unlimited transaction through StarkNet, and you pay for the gas and things like that.
Yeah, exactly. Yeah, it's actually as part of the way fees will be implemented, right, with the paymaster. So that's really the idea. So yes, dApps will be able to sponsor transaction for the users. You will be able to pay in any token. I mean, again, the possibilities are only limited by our imagination.
Yeah, and this is something where StarkNet really stands on the shoulder of giants. We really benefit from the experience of Bitcoin and Ethereum and other blockchains, but in this case, interacting with Ethereum for a long time did give us a lot of insight into how to build this.
Sounds good. Thanks again for having me.
No, wonderful. Thanks again for your time. And did you tell people where to reach out or where to?
So yes, very good. So we have within the StarkNet Discord, we have a dedicated channel called Argent Extension. So that's the best way if you have questions, if you want to provide feedback. So if you're on the StarkNet Discord, look for Argent Extension. We'll be happy to answer your question. Argent X is open source, so feel free to contribute. We're starting to have more and more contribution, which is really exciting. So again, we are building that for the community.
Amazing, thank you. Okay, so let's start with the following part. So I see a question here. F. Yusuf is asking, I thought that interaction between contracts was impossible on StarkNet. It is possible. Okay, so maybe my slides need a bit of correcting. But yes, of course, I mean, you can have contracts interacting with each other on StarkNet. So it is possible to have account smart contracts. All right, so let's talk about Cairo. So as we mentioned yesterday, so I hope you had a good day and you had time to digest a bit all of the information. As we discussed yesterday, StarkNet is written in Cairo, and StarkNet smart contracts are written in Cairo also. And Cairo is a specific language that allows you to create provable program. You can't just use any programming language to write provable program. You have to have a specific toolkit, basically. I won't go into the details here. If you're interested, for sure, ask me and I'll get more into the details. But the point is, we couldn't take any other language and just apply it to what we wanted. We had to create a new language, and that new language is called Cairo. So the objective today, what I'm going to show you is a small tutorial that will explain to you the basics of Cairo. It's a no-code tutorial. We're going to start gently. So tonight, you won't have to write any code. You just have to read code and then interact with a bit of the tools that we have in the ecosystem so that you get familiar with them. So let me share the link and share my screen. There we go. Okay, and I'm going to share the link here. The link is here. All right, so the way it works is the following. And you're going to see that this tutorial is a template for how our workshops tomorrow and next week or the week after that will work. Basically, they're a way for you to work and get corrections straight away to know if you're doing things correctly or not. There's a big README here that I invite you to read. Take time to read it. It will be much clearer what exactly we're waiting from you. But the basic gist of it is that there are a bunch of smart contracts deployed on StarkNet. For each exercise, you can read the code by clicking here, and it's in the repo, right? See here the little the repo architecture. I'm going to go back there after, but you'll see. And then you can also, and this contract is deployed on StarkNet in testnet. So you can access that smart contract and you can read from it just like you can on Etherscan, and you can write to it, okay? So the idea of this tutorial is for you, and these exercises are able to credit you points. You get nice points that, you get points that show up here. See here, I have 4 points, right? And for this one, I have 1,000 of this one. And you get points, and when you complete exercises, you get points. That's the basic gist of it. So it's a very easy way for you to understand if you have mastered a notion and if you have completed an exercise. There are 13 of them, and there's 2 points per exercise. So the maximum number of points you can get is 26. And we'll have at least 3 more tutorials like this over this hackathon. I will say this: if you manage to have more than 2/3 of the point in each and every tutorial, I'll give you some swag. So if you're able to show me that you've had 2/3 of a point on each and every tutorial by the end of this hackathon, I will send you a t-shirt or something cool StarkNet related. All right. So don't expect any gain or any kind of token from that. It's just for fun and for you to learn. And the real gain you'll have from this is knowledge. But if you want a t-shirt, do complete these exercises. So let's see. Are there crypto prices available? So, and the question is, should we do these before the next session? I mean, yeah, the objective with these sessions is for you to step up your Cairo game and step up your StarkNet game. Completing this tutorial will teach you a lot about how Cairo works. It will demystify it for you. And so if you want to get hacking and to be able to do cool stuff during the hackathon, I think they're a great way to start. You don't have to do them, of course, but the idea is to make it fun and easy for you to jump on. And by the way, if you think these tutorials can be made better, as you can see here, there are a bunch of contributors on the repo. We're open to suggestion. Do let us know what can be made better so that the next people have a easier time learning. Okay. So the way it works is the following. Here's the structure of the repo. I'm going to take a look at the README after. So in the contract folder, you get a bunch of smart contracts, right? These are all the contracts. And then folders with utilities. What I want you to do is to interact with this contract to collect points. So let's check the first exercise, right? So what exactly is happening in the first exercise? There's the declaration of the language of StarkNet. This means that this is a Cairo contract that is not just a Cairo contract, it's a StarkNet smart contract, right? And this is importing something we call built-ins. You can think of them as importing functions. Then we import other functions from other folders, right? And from other files. I won't go deeply into that right now because there's an exercise dedicated to that, and I invite you to check it. Then we have a constructor, just like you have in a Solidity smart contract. So this is the function that is called when the exercise is deployed. And then you have an external function. So these functions are callable by other contracts. They're callable by your, for example, by your account contract. So what does this function do exactly? It's called claim points. Here we have two implicit arguments that you don't really need to pay attention to, right? Take a look here in the comments, and there's a lot of information, and it takes no information as an input. What does it do exactly? The first line, okay, so it is declaring a variable, and it is getting the caller address. So this is basically the equivalent to getting msg.sender in Ethereum. And then after it has your address, it basically validates the exercise for you. So it says, okay, you completed this exercise, and then it sends you a point. Okay, so in order to complete that exercise, the only thing I have to do is call claim point. Sounds pretty straightforward, right? So I'm just going to go on Voyager here. I can see here in the read contract tab that there's a bunch of functions. I can call them later on. And here, indeed, I can see the contract, the claim point. Okay, function. Here's something important. You can see here that I have connected Argent X to Voyager. It's important to do so because doing so, right? I'm going to change my account. By doing so, by doing so, when I click on transact, the transaction is sent through Argent X. And so this means that this transaction technically will go through my account contract. It won't go directly to the smart contract, right? So Argent X takes care of that complexity for me. And once the transaction has been sent, I can check here and wait for a bit to see when it will be included. All right, so that's the basis of what you're going to have to do is this. Okay. So up is basically sending transaction and waiting for them to be included. So what happened exactly here? Here, there was an error. So the error is not great. It looks like here somewhere an assert EQ instruction failed. I'm pretty sure that what happened here is that I had already validated this exercise with my account. So I'm going to check. And yes, as you can see, if I go in the read functions, I can see that I had already validated my exercise. This is why I can't do it anymore. Okay, so no need to worry. I'll do this following exercise and see if I can do it. I'm going to check the questions. Ava, who wrote this out of interest? Yours truly, I did. So if you have any questions, let me know. Smiley Beast is asking, how hard is Cairo and what requirements are needed before coding in it? Difficulty is a subjective topic, right? Some things are difficult for some people and easy for others. Honestly, take a look at that tutorial. It's your best way to gauge whether this is difficult for you or not. This tutorial just requires you to read it, okay? What IDE do you recommend? For this tutorial, you don't need an IDE. You can directly do everything on GitHub. I personally, I'm probably not the best example, but I use Sublime Text. But I know a fair amount of my colleagues use Visual Studio Code or Visual Studio, and there's extensions to manage Cairo code, by the way. And then 361457 is asking when to use alloc local. Sometimes get caller address needs to be allocated. I don't have an answer to this question, and I'm sorry. And actually, it's a good way to introduce your best support resource for this tutorial. So your goal will be to follow the tutorial, to read the code, and each time to validate these 2 points, right? If at some point you get stuck and you have questions, you can jump into Discord. There you go. So you can join the Discord here. And once you're in the Discord, you can join the tutorial support channel here, right? And once you're here, you can ask any question you have, and we'll be here to answer. You can ping Lucas, who joined us last 2 weeks ago, and who will be happy to answer your question. You can tag me. Don't hesitate to add us. We're here for that, and we want you to be able to move fast. Okay, so these questions, for example, like why do you need to use alloc locals? I don't have the answer right now. There's a good reason for that. If you ask the question there, for sure somebody will answer it. Okay. Okay, so now let's see. I've done exercise 1. Let's check if I can do exercise 2. Up. So what exactly is happening in exercise 2? So exercise 2 has a bunch of new stuff, right? So, okay, this was the same as before. This is some imports. Ooh, there's some text here. I should probably read that. I'll leave it to you. Okay, and now there's a new thing. Okay, a storage variable. So my secret value. Okay, so this is a secret value. So this is a variable, right? It basically returns a felt. So it returns a value. So this is the equivalent of declaring a private variable in Solidity. Something important in Cairo, you can't declare a public variable. By default, when you declare a variable, it is private. And if you want it to be public, you have to create a view function to retrieve it. So here, for example, for my secret value, it is stored here. And here I have a view function that will read the value that is here and then return it, right? So if I go here on Voyager, I'll be able to read the contract. And indeed, here you can see that my secret value is readable. Okay, pretty cool. So that's the constructor, nothing fancy here. There's a function claim point. So what is this function doing exactly? Oh, okay, so this one takes a new value as an input. Okay, so it expects me to send some kind of value there, right? Yes, actually here, there's a value I need to put. So what is it doing exactly? Okay, msg.sender, it's reading my address. And then what is it doing? It retrieves the secret value, and then it does an assert. An assert is like a require in Solidity. So this is require my value equals my secret value. Okay, so it's basically checking that I have passed a correct value to call this function. So it is basically checking that I know the value of my secret value, and then it gives me point. Okay, pretty cool. So what do I do in order to validate this call? Simple. I have to read this by reading this function, by calling this function, and then call this function claim point with the proper value here, right? Okay, so if I go here, what is the value of my secret value? Okay, 31020. Then if I paste this here, transact, maybe it will work, maybe it won't. If I already completed the exercise, it won't work, but I guess we'll figure out soon. Right? Yeah, okay, so it's gonna fail because I already done the exercise. But actually, if you want to know if I already done the exercise, and that's something I'm gonna cover this later. Do we expect the test? I'm checking the questions. Do we expect the testnet transactions to take several minutes? They can take some time to execute. Yes, and sometimes yes, the network is a bit slow. This is temporary. StarkNet is still in alpha, and it should be much faster in the coming weeks. Can you drop unfinished TXs somehow? No, you can't. You can't because there are no fees in StarkNet, and so if you have two transactions with conflicting nonces, I'm not sure which one will be picked up by the sequencer. And also, I'm not sure the tooling is there yet to actually broadcast a new transaction with a conflicting nonce. Okay, but something I wanted to mention is the following. How do you track your points? Well, it's very simple. The points you receive. Yes. So is there an explorer you recommend? Yes. Voyager here. So the points you receive are tracked in an ERC20 contract. Here in the contract, it is stored, and you can see what is the address of that ERC20 contract. So if I go here, contract, I can actually go and see the contract, right? So it's an ERC20, should be familiar to you. So if I go in read contract, I can go in balance off, and I can check how many points I have, right? So how many points do I have so far? Okay, so I've done 3 exercises. I've got 6 points. I can do something cooler too. I can add this token into Argent X so that it displays directly here, right? I'm going to go to add token, contract address, and boom, I have it. And here you can see I have 6 points. Okay. So what are the limits of StarkNet in terms of throughput and transaction speed? Right now, blocks should be finalized every 2 minutes on this net, and transactions should go through at about the same speed. And as we mentioned, by the end of this semester, we want to have 10 times the amount of transaction that Ethereum has at 100th of the cost. But right now, you should expect your transaction to be able to go through you should expect your transaction to go through in about 2 minutes. James is asking, has Voyager the same functionality as Etherscan? It's similar. It's similar. All right, so back to the tutorial. As you can see, I've done exercise 1 and 2, and then the basic of this tutorial is this. You just need to go one by one, following them. And this is not a typo. Exercise 12 was written after, but this is the nice place to do it in the progression of the exercises. And so basically, you can follow each exercise and gather point. Yeah, so I see there's another question. I thought you were working on normalization of contracts with Open Zeppelin, but ERC20, ERC721, and ERC1155 an account already. So Open Zeppelin is indeed working on on writing standard smart contracts. They have a bunch of contracts that are usable today. They're not production ready yet, and this is why it's a bit harder to integrate them in your smart contract than on Solidity, for example. But if I recall correctly, they want these to be installable with a pip package, similar as you can install them with NPM on Solidity by the end of this semester. Similar to Ganesh, can we fork StarkNet for development purposes? Yes, there are plugins that allow you to do that with Hardhat. You can use the DevNet and you can fork the mainnet, I think. Once again, for this tutorial, you don't need to do that immediately. I could speak for a long time, but to be honest, I think that doing this tutorial will explain to you much more about Cairo syntax than what I could ever explain on video. So I think if you want, what we can do is I can stay here in standby and I can answer your questions if you have some. And if you want to start working on the tutorial, I think the hardest part is getting started. But once you have you've done the first 2 exercises, you're set. You'll probably be able to finish the tutorial. Do take time to finish it. And yeah, if that's fine with you, we can do this. I'll stay here if you have questions. And yeah, that's the whole point of this session, is to get you to work on your own. And by the way, you can do this session right now, or you can do it in the coming days. Again, I suggest you do it before next tutorial, because for the next tutorial, you'll have to actually write code. And so knowing the syntax will be much more helpful then. So yeah, highly suggest you do it before. And again, if you manage to get enough points, you'll get swag.
Perfect. Thanks, Henry. I'll stick around with you if anybody's got any questions.
Peter is asking, will we cover bridges? Yes, we will. So yes, basically there's a very cool functionality in StarkNet that allows you to send messages back and forth between L1 and L2, and allows you to build really cool and complex apps between L1 and L2. And this will be the topic of a workshop that will happen, I think it's in 2 weeks. It's not next week, it's the following one. Don't want to say anything stupid here. Yes, it's on miércoles 16 of March. So be there. It's going to be interesting. I think the bridge functionality, like bridging messages between StarkNet and L1, is one of the it's a very interesting building block and a very interesting brick. So yeah, do get excited about it. Right, actually, I'm going to share my screen again. So see, I sent a transaction a few seconds ago, and its status has moved from received to accepted on L2, which means that my transaction was taken into account. Here, as you can see, the StarkNet 101 balance has not been updated yet. Sometimes Argent X it takes a bit of time to update the balance. So if you want to know how many points you got and you want to have a more relevant vision, you should go here directly in the Voyager. But actually, I'm saying I'm bad mouthing Argent because it's not their fault. It's because I didn't complete the exercise. I'm actually completing exercise 4. So what is it doing, right? So I called assign user slot. It's taking my name. It's reading a variable called next slot, right? If next slot, then it reads the value in the storage at next slot. If the value is 0, it means it was not initialized. So it gives me slot 1, and it initializes at 0. If not, it increments by 1, and it gives me the value at slot 1. Okay, so now I should have a slot, right? So if I look at user slot, this storage variable is taking into account my account and sends me back my slot, right? So let's check. So read contract, user slot. Yes. So what's my account? It's this. Okay, so I have user slot 65. What do I do now in order to claim point? I have to send expected value. So I have to read, so it's comparing expected value with the value that it is reading at my slot. Okay, so I got a value assigned, which is at slot 65. So now I need to retrieve it. So if I values mapped is this one, slot 65. Okay, so this is my value, 7056. Okay, so I need to send 7056, but actually I need to send something different here because it is adding plus 32 here. Yes, I'm a bit sneaky sometimes. So, okay, so the value here should be expected value plus 32. So this means I have to put 7056 minus 32, which is 7024, I guess. Let's see. All right. So claim points here, 7024. Florian is asking, is exercise 3 to be omitted? I see you're working on exercise 4. No, I'm working on exercise 4 because I already completed exercise 3 before with this account. But you should do it. I mean, if you don't do it, you won't get the points, and then you won't have the full 26 points. Actually, I'm very curious, how many of you will manage to get at least 10 points, and how many of you will get the full 26 points? Be very curious. I mean, are you up to the challenge? We'll see. So, will StarkNet have, Peter is asking, will StarkNet have issues with reorgs due to congestion like Polygon? Or does it deal with those block issues differently? That's a good question. I think for now, we have an execution engine that is able to take provable code and execute it and secure it with L1. The question you're asking is really a matter of consensus to me. How do we get to move the chain forward and agree on the sequence of block that will be included? And since this is largely a topic of research today, and we haven't even settled on the actual algorithm that we're going to use, I feel like it's a bit early to say we won't have this issue or yes, we will. Yeah, so I can't really comment on that. I'm sorry. My transaction was accepted. Cool. Did I get points? Yes, I did get points. See, and it updated quite quickly. I'm happy. So I validated an extra exercises. Okay, so Florian is saying, no, it's cool if we can do it alone, but can you explain general stuff about Cairo, like felt, that could be useful? Yes, that's right. It's something I didn't explain, and I'm surprised actually I didn't get the question. So if you've seen here, so let's take, for example, this storage variable. So this storage variable is called value mapped storage, right? And this is actually equivalent to mapping in Solidity. It takes an index as an input, and it returns a value, okay? This input here, this is the name of the input, and this is the type of the input. And as you can see, the type is what we call a felt. Felt is an acronym for field element. I'm going to give you the broad overview, and then if you want, I can give you more detail. A felt is basically like a uint that you would use in Solidity, except instead of going from 0 to the power of 2, instead of going from 0 to 2 to the power of 256, it goes from 0 to a very large prime number that is of the order of 2 to the power of 251. Okay, so that's this. You can use it in your Cairo contract kind of like you would use a uint 256, but you have to be mindful that if you're dealing with L1, for example, then if you're sending uint 256 between Ethereum and StarkNet, your uint 256 might be too big to be stored in a felt. And so that's why in Cairo, I don't know if we have that here. Let's check. No, we don't have it in that tutorial, but basically in Cairo, if you want to manipulate a uint 256, I can show it to you here actually. If you want to manipulate a uint 256, you have to use two felts because one uint 256 is bigger, can be bigger than one felt. So this is why, for example, here when you're querying your balance on the account contract, it returns you 2 digits. high and low. This is the high felt and the low felt, and the combination of both is a uint256. Okay. Nader is asking which programming languages are close to Cairo. I mean, in syntax, Python, I'd say. It's largely inspired by Python. So coming back to felts, why exactly is Cairo different, and why are felts necessary in the first place? Couldn't we have used uint256? And the answer to that question is that Stark proofs are at their core a mathematical tool to prove that you know the solution to certain equations. And on top of that, we've built complexity that allows you to express programming language. This means that technically what the instructions to your computer compile to is Boolean logic, transistor logic. What Cairo instruction compile to is arithmetics logic. So it's different than Boolean. And this makes it that it has some specific property, one of them being that you don't get to use the same kind of fields because 2 to the power of 256 is binary logic, and Cairo is not based on binary logic. Now, will felt stay forever? That's actually a current point of debate amongst the development teams in StarkNet. Some people are saying no, but you know, felts are confusing. I want to use uint256, and I don't want it to be complicated to use. I don't want to hear about felt. Even if it takes 2 slots, I don't care. And others are saying, no, I want to make the application as lean as I can. And if I can use 1 storage value instead of 2, I want to be able to do it. So it's really a big question of whether we want to abstract this kind of notion to make it more developer friendly, or if we want to leave this possibility. Right now, you have the possibility to use both. So Florian is asking, what are the parameters of claim points of the first contract? I think you're talking about the implicit arguments which are there, right? So the way Cairo works is that it's a program. It's a program that is executed sequentially, and you can't rewrite a memory cell, and so it works with a stack pointer. And for some functions, you need some specific functions that are inserted by the compiler, and specifically these ones that are, for example, these ones that are declared here, or syscall pointer, Pedersen pointer, range check pointer. These are basically values that point to a location in memory where you have precompiled tools that let you do some kind of action. So for example, syscall pointer, I think, is used to determine what is get caller address. This is in order to hash stuff. So when you want to call another function and things like that. Since when you call a function, you make a jump in memory, you need to tell to this function if this function needs, say you want to call function A, and in that function A, you will need the built-in syscall PTR, the syscall pointer, right? You want to make some syscalls. Then your function A will need to know where to look for these for this precompiled code. So when you call it, you tell it also, by the way, here is where you can find the syscall pointer. They're implicit argument in the sense that you don't need to specify them when you call your function, but you do need to put them in the function declaration. I personally think that it sucks that you need to put these things here. But that's the way things are now. It's a bit complex, but it will get simpler with time. Does that answer your question? Is that clear? Don't hesitate and tell me. Peter is saying, I vote for flexibility. Haha, so Peter is a hardcore optimizer. Good for you. I think flexibility is nice too. I think it's good to have people who want to be as close to the metal be able to do so. Kezon is asking, do you have a reverse compiler? I'm not sure what you mean. Probably you mean something that will allow you to take compiled bytecode and get Cairo code from that. And no, we don't have that. That being said, something interesting. You've noticed here when I deployed my contract that it's really nice. I got the read contract and write contract tab. And I even get a code tab. Oh, I could actually verify the source code. You want to try to do that together? That's new. You think it work? Ooh, spoiler, we get this one for you guys. So this one, which one is this one? It's exercise 1 or exercise 4? It's exercise 4. Okay, let's try to do exercise 4. But yeah, I'm going to finish what I was saying. When you deploy your contract to StarkNet, right now, since we're the only sequencer, we use this opportunity to actually make the code available and visible to people. So the compiled bytecode and the IBI of the contract are sent to the sequencer, and they're made available by the sequencer. So Voyager here, when it indexes the chain, it gathers the code and it gathers the ABI so that you are able to interact with it very quickly. It's difficult to know if we're going to keep it that way for a long time. Let me check. But because there are some drawbacks to this, but what was I saying? But right now it works that way and it's very easy. Okay, so no. What exercise 4? I don't think this will work. Okay, I'll check it later on. Anyway, transpiler forthcoming, I think. Oh, okay. So I don't know if that's the question you had, Kesson, or if Peter is right. Do you have a reverse compiler? So we have a transpiler, which allows you to take Solidity code and transpile it to Cairo. It's called Warp. If you're curious, you can try to use that. Don't hesitate and use that for the hackathon if it's useful to you. You need to write your Solidity code in Solidity version 8, but you can basically transpile it to Cairo very easily. And I've seen that they have a very impressive update coming soon that will make it possible to have even better performances when you're doing that. I hope you'll get you'll learn you've learned something today, and that you'll learn more even in the next session. And yeah, don't hesitate, pop by in Discord in the tutorial support, and we'll be here to answer your question. All right, Jake, do we have more questions, or should we wrap it up?
Nothing. I think let's wrap it up. Another excellent session. Thanks, Henry.
Wonderful. Have a good night.
Perfect. Cheers. Cheers, guys. Thank you so much for being there.